let's talk about solving equations with u-substitution. Now, there are some types of equations that look similar to quadratic equations, but are not exactly quadratic. However, in certain cases, it's possible to make a substitution in order to create a quadratic equation. So, this first example, x to the fourth minus 5x squared plus 4 is equal to 0. A quadratic equation has the form ax squared plus bx plus c equals 0. One of the most important parts here is that the highest degree of any exponent is 2. And that certainly isn't the case with our example. This degree is 4. So it's not a quadratic. However, it's very similar to a quadratic equation. And what I'm going to do is try to make a substitution in order to turn this into something that is quadratic. So for instance, let me mess around with the exponents and use the rules of exponents to change this into a form that looks like x squared squared minus 5x squared plus 4 equals 0. Now, the reason I've done this is because if you'll notice now, this first term, if I made a substitution and said u equals x squared, all right, so here's what's going to happen. So this x squared is going to change into u, and this x squared is going to change into u. So the remaining parts that I have, this is still squared, this is still times 5, or negative 5, plus 4 equals 0. And the important part about that is now if I take away these parentheses that are no longer necessary, I have u squared minus 5u plus 4 equals 0, which does qualify as a quadratic equation. If you go back up to this equation here, it's using a variable u instead of x, but that's okay. It is in fact quadratic now. So a quick substitution of u equals x squared could turn this into a quadratic equation. So let's solve this particular equation and see what we come up with. Now it looks like this should factor. So I'll put u and u here. 4 could be either 2 and 2 or 1 and 4. I think 2 and 2 is not going to work because I need them to add to 5. So 4 and 1 look like good options here. And if they're both negative, they would multiply to positive 4, and they would also add to negative 5. Now, I can set each one of these factors equal to 0 and solve them individually. So I have u equals positive 4 and u equals positive 1. But the original equation was in terms of the variable x. And so I haven't really solved my original equation. I've solved a slight change of my original equation. But I can get back and change it back to what I want using this same substitution that got me here. So here's what I'm going to do. I'm going to now change u back into x squared for both of these two equations. Because I know u is equal to x squared, I can interchange those two variables at any point. So this would be equal to 4, and this would be equal to 1. Nope, let me get rid of that so it doesn't look like a negative 1. All right, now if I have x squared is equal to 4, then I could take the square root of both sides and say x is plus or minus square root of 4, or x is the plus or minus 2. Likewise, x equals plus or minus square root of 1, or x equals positive or negative 1. Now I've solved my original equation. Positive and negative 2, positive and negative 1 will solve this original equation here. So, for instance, I could check it just by plugging in any of these values. So if I put positive 2 in, raise that to the 4th power, minus 5 times positive 2 to the 2nd power, plus 4, that should equal 0. Well, 2 to the 4th would be 16. 2 squared is 4. 4 times 5 is 20, so minus 20 plus 4. And it looks like that does equal 0, because 16 minus 20 is negative 4. Negative 4 plus 4 does equal 0. And if you'll notice, nothing really would have changed if I had had negative 2 in there, because I'm raising negative 2 to positive exponents, or to even exponents, which makes positive answers. So it doesn't matter if I started with positive 2 or negative 2, I would get the same result. Same thing for 1. If I do 1 to the 4th minus 5 times 1 squared plus 4 equals 0. Well, this would be 1 minus 5 plus 4. So 1 minus 5 is negative 4. Negative 4 plus 4 is in fact 0. And again, if I would have begun with negative 1, that would have been okay. Gotten the same results because I'm raising it to an even powered exponent. So they work out. All 4 solutions work. So let me go back and talk about another point real quick. So the degree of this equation was 4. When we had something that was degree 2, there was always 2 solutions. Here I have something that's degree 4, an equation that's degree 4, and I had 4 solutions. So it seems to be implying that the degree indicates the number of solutions that you should have in the end. Let's work some more examples. 10 times x to the negative 2nd power plus 3 times x to the negative 1st minus 1 is equal to 0. All right, so we need to figure out how to manipulate the variables here, the exponents of these variables, so that we come up with something we can substitute in and make it quadratic, because it's not quadratic currently. So the thing to kind of pick on here is this part right here, because what I'm going to want to do is get that to change into just u. So there's a really good chance u is just going to be x to the negative 1st power. And if that's the case, then right here, I need to change this into something involving x to the negative 1st power. Well, 2 times negative 1 would be negative 2. So I could make this x to the negative 1 squared. Plus 3 times x to the negative 1 minus 1 equals 0. So this will change into u, this will change into u, and I'm going to have 10 times u squared plus 3 times u minus 1 equals 0. Or 10u squared, just getting rid of the parentheses here. And let's try to factor this. Ten could be either 1 and 10 or 2 and 5. 1, the only factors of it are just 1 and 1. So let's work from there. I need things that will add up to 3. So 10 and 1 are probably not going to work. So I think 5u and 2u are my options here. So I need it to be a positive 3, so I think the 5 needs to be positive, and the 2 needs to be negative. So this will work for factoring. So 5u minus 1 times 2u plus 1. Now if I set each one of those factors equal to 0, so 5u minus 1 equals 0, 2u plus 1 equals 0, then I get 5u equals 1, or u equals 1/5. 2u equals -1, or u equals -1/2. Now, I have to go back and substitute right back to where I started. So u is equal to x to the -1. So I'm going to change u into x to the -1. And change u into x to the -1. Now, this may look a little bit strange, this x to the -1 power. But if you'll recall your rules of exponents, x to the -1 just means to take the variable x and put it in the denominator. So I have 1 over x equals 1/5. And over here, 1 over x equals -1/2. And this is something that I can solve by cross multiplication. So if I multiply x times 1, that's just x. 5 times 1, that is 5. So x equals 5 is a solution. Here, if I take x times -1, I've got -x. 2 times 1 is going to be 2. And when I get x by itself, x equals 5 and x equals -2. Those are my solutions. In this next example, this one's a little bit easier to see what u is going to be because it's already set up in such a way that I can just basically substitute. U, if you haven't guessed already, is going to be x plus 3. So I change this into u squared, and I change this into minus 2u plus 2 equals 0. And solve it for u. Factoring, it doesn't look like it's going to work here because the only factors I have of positive 2 would be 1 and 2. And there's no way to get that to add to -2, which means I'm going to complete the square. So I'm just going to move the positive 2 to the other side, and then the term multiplying u is -2, or the coefficient that is, and I'm going to take that number divided by 2, which is 1, and square it. So just rules from completing the square. So I add 1 to both sides. This factors into u minus 1 quantity squared equals -1. And if I take the square root of both sides, u minus 1 equals the plus or minus square root of -1. And if I add 1 to both sides, it just moves that over. Reduce this square root to just I. That's where I am currently. Now, I have to substitute back. Now remember, u was x plus 3. Notice this notation though. It's going to be a little bit easier if I split this up into 2 separate equations here. So I'm going to split this up into u equals 1 plus I and u equals 1 minus I. So that's what the plus or minus means. I have 2 solutions. One has a plus in between, one has a minus. All right, now I'm going to substitute back in for u. So u changes into x plus 3. So I have x plus 3 equals 1 plus I, and x plus 3 equals 1 minus I. This may look like it's a tricky thing to do here, but all I'm doing is subtracting 3 from both sides to get x by itself. And when I have a complex number and a real number, I just add the real parts, add the complex parts separately. So 1 minus 3 is going to be -2, and there's no other complex parts other than just plus I. So -2 plus I. Over here, if I subtract 3 from both sides, cancels that, and I get x equals -2 minus I. This next example, what I'm going to do here is, again, just kind of noticing that middle term here is pretty much the thing that's going to equal u. So I need to rewrite this in a form that the first term here can be expressed as that. So x to the 1/3 squared. 1/3 times 2 would be 2/3. So minus 7 times x to the 1/3 plus 10 equals 0. So if I let u equal x to the 1/3 power, u squared minus 7u plus 10 equals 0. And it looks like this will factor, so that's nice. So u and u, this would be 5 and 2, and they're both going to be negative, so that negative 5 times negative 2 is positive 10, negative 5 minus 2 is negative 7. So I have u minus 5 equals 0, u minus 2 equals 0, which means u equals 5 or u equals 2. Now, when I substitute back, u is x to the 1/3 power. But let's take a minute to recall exactly what that means. So when I have something to the 1/3 power, that's the same thing as the cube root of that value. In the same way, x to the 1/2 power is the square root. So if I want to solve this equation, x to the 1/3 equals 5, what I'm going to do is cube both sides of this equation. So 3 times 1/3 cancels out and just gives me a 1. 5 to the 3rd is 125. Likewise, right here, if I cube both sides of this equation, x equals 8. Okay, here's another example. Plenty of examples here, so you get used to what to do. In this case, the middle term is x squared, so that's a really good hint that u is going to have to be x squared. Now, if you'll notice, x to the 4th can be written as x squared to the 2nd power minus x squared minus 5 equals 0. Which means when I substitute, I'll have 4u squared minus u minus 5 equals 0. And let's see if this factors. So factoring here, 4 could either be 1 and 4 or 2 and 2, but I know that 5 has to be 1 and 5. Those are the only factors of 5. So let's see, if this was 2u and 2u, well, what would happen here? 2u times 5 would be 10u. 2u times 1 would be 2u. And there's no way that I'm going to get that to add up to negative u. So these factors aren't correct. So let's try another. Hard to erase here. I'll just erase the whole thing. Okay, so then we know that the last two have to be 1 and 5. And it's not 2 and 2 for the first. It could be 4 and 1. Now when I choose my 4 and 1, let's see. I'm going to put my 4 right here and my 1 right here. The reason for that is because, like, if I multiply 4 times u, that's going to give me 4u, and then 5 times u is going to give me 5u. If I'd done it the other way, I'd have 20 and 1. So these can definitely add up to negative u if the 5 is negative and the 4 is positive. So that works out. Now, when I set each of those equal to 0, u plus 1 equals 0, 4u minus 5 equals 0. So that means u equals negative 1, 4u equals 5, or u equals 5 fourths. Now, remember, we defined u to be x squared, so I need to substitute back in for that. So this changes into x squared equals -1, so that x equals plus or minus the square root of -1, or plus or minus I. Here, x squared equals 5/4. When I take the square root, I will have the plus or minus square root of 5/4. And the nice thing about fractions is when you have the square root of a fraction, you can do the numerator and denominator separately. So this could actually be plus or minus square root of 5/4. And there we have our answers. Oops, sorry. Gone. Square root of 5/2, because the square root of 4 is 2. Next up here, this one, again, it looks complex, but if you'll notice, it's kind of telling us right from the start that my u needs to be x squared minus 1. So when I substitute, this becomes u squared. This becomes u minus 6 equals 0. And this will definitely factor, which is nice. We don't need to use quadratic formula or completing the square. 2 and 3, if the 3 is positive and the 2 is negative, it works out. So u minus 2 equals 0, and u plus 3 equals 0. So u equals 2, u equals -3. And now I just need to substitute back. So x squared minus 1 equals 2. X squared minus 1 equals -3. And when I solve each of these, I will add 1 to both sides. So x squared equals 3. And when I take the square root, it's going to be plus minus square root of 3. Over here, add 1 to both sides. So x squared equals -2, or x equals plus or minus the square root of -2, which reduces to I times the square root of +2. Just factor out the negative underneath the root as I. And my last example, this one is a little bit trickier than most, but it's still very doable. I'm going to spell out how I'm going to change this in such a way that I can make a substitution. So I'm going to write it like this, minus 5, and this is still just going to be x minus 1 to the 1/3, and plus 3 equals 0. I'm going to bring that 3 over. So u is going to be x minus 1 to the 1/3 power, which turns my equation into 2u squared minus 5u plus 3 equals 0. And let's see if we can get this to factor. All right, so 2 has to be 1 and 2, 3 has to be 3 and 1. So there aren't many options of what this could be. So I could have 2u and u, and this could be 1 and 3, or this could be 3 and 1. That's the only options here. So let's check and see if we can get 1 and 3 to work. So 2u times 3 would be 6u. 1 times u would be u. All right, it looks like it might work. Let's see what we can get for the constant. So we need this to be -5u. So we would need -6u and +u. And that would add to -5u. But if you'll notice, +1 times -3 would be -3. So the constant doesn't work out here. So this one's a little bit trickier. Let's try another combination. Now our only other option was 3, and 1. So let's see what happens when we do this. So 2 times u, or 2u times 1 would be 2u. 3 times u would be 3u. And what happens here? So we need these to add up to negative 5u, so they both need to be minuses. Negative 3 times negative 1 is positive 3. This works out. All right, so I have 2u minus 3 equals 0, and u minus 1 equals 0. So solving each one of these, 2u equals 3, u equals 3 halves, and u equals 1. Now, just bring it down here. My original variable u was x minus 1 to the 1/3 power. So I'm going to substitute that in. So x minus 1 to the 1/3 power is equal to 3 halves, and x minus 1 to the 1/3 power is equal to 1. So this 1/3 power, it's a cube root. To get rid of it, we have to do the opposite. The opposite of a cube root is a cube. So we're going to cube both sides of this. So I get x minus 1 equals, and if you're cubing a fraction, just cube the numerator and denominator separately. So 27/8. Over here, if I cube both sides, I get x minus 1 equals 1. Now I'm going to need to get x by itself, so I need to add 1 to both sides of this, but I need common denominators, so I'm going to change that 1 into 8 over 8. So x equals, let's see, 27 and 8 is 35. So 35/8 is the answer here. And if I add 1 to both sides on this equation, I get x equals 2.